So I'd like to first preface this video with the fact that I turn a servo, which can only move finite directions, both clockwise and counterclockwise, into a continuous rotation servo that can move continuously counterclockwise and clockwise. To do so, all I do is, as we'll see in the video, I cut the contact from this top gear to the potentiometer so that the potentiometer has no knowledge or no information about this gear's position. You'll see that later in the video. Now, I also use a transmitter and I connect channel 4 of the transmitter here to the servo so that as I rotate the rudder stick, the servo is able to rotate both clockwise and counterclockwise, as indicated by me moving the rudder stick left, then right. It's very important that once you get the potentiometer in its neutral position, that you do not change any of the position of the trim on the rudder. Otherwise, you'll notice that the potentiometer, the servo will then move. That's all I'd like to say, and it should help in following the video. So thank you, and I hope you enjoy it. In this video, I'm going to demonstrate how to make your servo turn continuously. At the moment, this servo only turns in a finite angle. In the future, once this video is done, you'll see how you can make this servo turn continuously, theoretically, to an infinite number of radians. Let's begin. First, you'll need to take out each of these screws on the bottom of your servo. Once you get to the last screw, you'll see that you now be able to open up the servo. Let's open that. And now you see the gears that take the inputs from the servo motor and give an output to the servo horn here. As you can see. So at this step, we'll have to take out all these gears. So it's important to take a picture or remember the position. In fact, before doing that, it's a good idea to unplug your servo so that the gears do not move while you take them out and harm you. Once those top gears are taken out, we'll also be able to remove the bottom half. It appears the sticker is hampering the effort, so let's take off the sticker. Alright, so we've removed the sticker. And now we see the inner workings of the servo. So here is the servo circuit board. Here is the servo motor. And inside here, these 3 wires connect the servo motor and circuit board to a potentiometer. All a potentiometer is a variable resistor that the servo uses to determine its position. Our goal is to remove the contact here, which would turn the potentiometer, and manually move the potentiometer ourselves to a neutral position. Therefore, when we command the servo to turn left, it will turn continuously left because there will be no record in the potentiometer of it reaching its full left position. Same for the right side. So we'll actually use these heavy-duty metal cutters to cut this eventually. For now, we're going to replug back the servo in fact, we should also take out these gears. All gears need to be taken out. All right. Now we can replug the servo. As you can see, the DC motor spins continuously because there is no recorded track record of where this output is, because it's not connected to the potentiometer, as you can see. So this means that the potentiometer is currently in its neutral position. We can manually turn the potentiometer to see what would happen if it's not in its neutral position, which may be the case for some of your servos. Okay. So as you can see, as I turn the potentiometer, the DC motor also turns. Now, it's important to set the potentiometer at its neutral position where it will not be moving, where the motor will not be moving. As you can see, that position can be a bit tricky to establish. But once you've established it, you'll want to make sure that the setting on your radio transmitter is also in neutral. In my case, I've connected my servo to the rudder channel, or channel 4, and I've made sure that all my trim on my transmitter is set in its neutral position. Therefore, if I turn the rudder stick left, the servo motor will turn left. If I turn the rudder stick right, the servo motor will turn right. Now that we've done that, you'll carefully want to remove the gears while keeping that potentiometer in its initial location. There we go. So as we established before, the servo motor can now turn fully clockwise and counterclockwise. So next up, as you can see here, that focus. Okay, there's a divot This divot is what slots into the potentiometer. What we're going to want to do is cut this rod slightly above this divot, yet maintain enough length of the rod so that it can still slide into its hole. So to do that, we're going to use the heavy-duty wire cutter, and we're going to cut slightly above the divot, like so. In fact, you can actually stop when the divot ends to ensure you don't cut too much. For this part, you may want to make sure that you're wearing safety glasses and that there's no one around you. And cut. So as you can see, we've now cut the divot, and we can place that back into its respective hole. As you can see now, I'm able to freely turn the DC motor left and right using my transmitter, and these gears no longer have any influence over the potentiometer, which would control the DC motor via the circuit board. Okay, so now for caution, it's recommended to use, for instance, some sort of adhesive, for example, hot glue, to make sure that this position does not change. So to continue, I'll now reassemble the gears and close the servo. So as you can see, the servo is slightly turning. In order to counteract this, on your trim in the respective channel that you're controlling, you'll just have to moderate that. There'll be slight changes in the potentiometer position. However, I have hot glue warming up right now, and once I have that, I will put it on this potentiometer, as you can see here, to restrict its movement. So for now, while that's heating up, I'm going to reinstall the gears. If I remember how. Patience. Alright, so the gears have been reinstalled. As you can see, the servo turns continuously as we want it to in the beginning of this video. It can turn continuously clockwise as well as counterclockwise. can also modulate the speed at which it turns, from low speed, high speed, no speed, low speed, high speed, no speed. So hopefully the hot glue is ready, and then I will put it on this position here over the potentiometer. So the hot glue is now ready, and I will simply put a small dab over the potentiometer, which is outputting as this circle here. So I want to make sure that if this circuit board jostles when it's inside the servo, it does not move this potentiometer. That would be very bad, because it would mean that the servo will move unexpectedly. Now the servo could be in an aircraft, it could be in a boat, so it's very important that it does not move. So I put about a dollop. A dollop of hot glue. And as you can see, just with that, it's moving slightly. So I will adjust the trim position on my transmitter and make sure that the new potentiometer position is now the neutral position for the servo. Alright, so I'll then wait for the hot glue to dry. Now the hot glue is dried, so now it's time to reassemble the circuit board back into its position in the servo. Alright, so as you just saw, I've successfully closed the servo. Gear fell out, but we can just put that right back in. Like so. Alright. Final steps are to close the servo. As you see here, servo closed. Make sure that there are no wires outside of the servo besides the one that's supposed to be the output, this one here. And now all that's left is to screw in the remaining screws. So there you have it. We can now put on the servo horn and see that the servo is continuous rotation, both clockwise and counterclockwise, with variable rotation rate from low speed to high speed in both directions. So it could move in the clockwise direction, counterclockwise direction, and stay in the neutral position as you see below. Thanks for watching, and I hope that this was useful for you. I know that I've seen various other videos on this topic. I decided to make my own to make it as clear as possible for you. Thank you.